This is Teacher Ronnessa, your Science 9 teacher, welcomes you to an exciting and meaningful discussion about energy transformation. This topic has the following learning objectives. 1. Identify the forms of energy present in the operation of simple toys. 2. Describe the energy transformation in various events or activities such as archery, waterfalls, and amusement rides. Last but not the least, explain the law of conservation of mechanical energy. So again, learners, these are the objectives of this topic that you should meet at the end of this discussion. So before we proceed, let's look over or review the previous discussion. Do you still remember it, learners? So what are the two forms of mechanical energy then? In our previous discussion, we discussed about the two forms of mechanical energy. 1. Potential energy. It is the energy in motor due to arrangement of its parts, its composition, location, and structure. It is commonly considered as stored energy, having the potential to do mechanical work. The various forms of potential energy are chemical, electrical, gravitational, and elastic. 2. Kinetic energy. It is the energy in moving matter and wave. Some forms of kinetic energy are the following: motion, radiant, sound, thermal, and wave. You're really working hard today. Because of that, give yourself a round of applause. So now, learners, I want you to look at on the screen. So what are these two objects? That's right. It is a dry cell or battery and a wall clock. Questions. What form of energy does a dry cell stores? Correct. It is a chemical energy. Do the hands of a wall clock move without battery? Very good. The answer is no. Now, if you're going to insert a battery in a wall clock, what happens to the hands of it? Brilliant answer. The hands of a wall clock will start to move once you inserted a dry cell or a battery in it. So in order for you to understand more the lesson, let's do this simple activity entitled Little Shop of Toys. So these are the materials needed. So after you have prepared all the materials needed, please read and follow the procedures carefully and also answer the guide questions on a separate sheet of pad paper. Impressive, learners! You just finished the activity on time. So what are the changes in the mechanical energy in simple toys like yo-yo and the friction toy car? So let's check this out. A yo-yo drops and its potential energy changes to kinetic energy. As the yo-yo falls, its string unspooling, it spins faster. Some of the energy that would go into falling has been transformed into the rotational energy of spinning. So about halfway through the fall, the yo-yo's descent speed actually slows. When you hold the yo-yo in your hand, it has potential energy. It stores energy because it's high above the floor. When you release it, the potential energy is gradually converted into kinetic energy. So in the case of a friction toy car, simple friction toy car is spring-driven. It has an axle that wins the spring when the back wheels of the car are pushed backward against a high friction surface. As the car is pushed down and pulled backwards, the forward frictional force between the wheels and the running surface stored elastic potential energy in the car, as a spring is tightly wound during this process. When the car was released, the spring unwinds, spinning the converted into kinetic energy of the moving car. All through this process, friction is at work, and some of the potential and kinetic energies are converted to heat and sound energy. In the activity that you perform, Little Shop of Toys, you just identify the different forms of energy and its changes in simple toys. Indeed, when this energy got transferred or transformed, work and heat plus other forms of energy were produced, like sound and light. And some of this energy can also be stored in other forms. In general, when you made each toy or object operate in the activity and let it move, then the physics behind the toys caused transformation of mechanical energy from potential energy to kinetic energy, or from kinetic energy to potential energy. According to law of conservation of mechanical energy, energy cannot be created nor destroyed. It only transforms from one form to another, but the total amount of potential energy and kinetic energy remains constant. This means that the total amount of potential energy and kinetic energy in an isolated system is the same before and after any process. So now, ponder on these questions. What are the similarities of mechanical energy present in a stretched bowstring and a roller coaster car? And what mechanical work can be possibly be done by the transformation of these mechanical energies? So let's check this out. As she stretches the arrow, he increases the bow's shape. The farther the string is pulled, the more energy is stored and the greater the bow's elastic potential energy produced. Once she releases the arrow, potential energy causes the arrow to move at a greater speed, which is converted into kinetic energy. Energy is just transferred from one form into another form of energy. This energy transformation results to mechanical energy conservation. Question: how can a potential energy of a roller coaster car be transformed into kinetic energy? In the case of a roller coaster car, positioned at its maximum height, possesses gravitational potential energy, which causes it to move at its maximum speed. Energy in position is changed to kinetic energy. Now, as the car drives up to the highest position, its kinetic energy becomes zero, transformed into maximum potential energy. Energy is not lost, it is gained by potential energy. A large amount of gravitational potential energy is possessed by the car in the highest position. Remember, the gravitational potential energy depends on the mass and the height of the object. So, the higher it is positioned, the higher its gravitational potential energy. And as the roller coaster car descends, it speeds up and gradually gains kinetic energy, which is dependent on the mass and the speed of the object. The original potential energy is transformed into kinetic energy. Now, in the absence of air resistance, the total mechanical energy is conserved during the ride, and the total sum of potential and kinetic energy is constant throughout the ride. Sustainable Development Goal. The Sustainable Development Goal 7, Affordable and Clean Energy. Its target ensures universal access to affordable, reliable, modern energy services and increase substantially the share of renewable energy in the global energy mix. Investing in solar, wind, thermal power, improving energy productivity, expanding infrastructure, and upgrading technology to provide clean and more efficient energy in all countries will encourage growth and help the environment are some ways to achieve affordable and clean energy. And to evaluate yourself if you really learned something, let's do the self-assessment entitled Celebrity Blog. In your assessment, you are going to identify whether the statement is fact or bluff. Fact if the statement is true, and bluff if the statement is false. Write your answer on a clean sheet of paper. You are given 5 minutes to finish this. Timer starts now. Congratulations, learners, for a job well done. Give yourself a round of applause. So this ends my discussion. Thank you and stay safe, everyone.